All right, so we're going to be doing our lab here to investigate and see if the relationship between work, force, and distance is what we think it is and what we've been taught it is. All right, so the way that we're going to do that is we're going to calculate the work done based on the force exerted and the distance over which that force is exerted. Okay, now what kind of a relationship should that be if the formula for work is this? What kind of relationship is that going to be? Should be linear. Okay, we should get a graph that has a best fit line, a clear best fit line, not a curve or anything like that. Okay, so that's what we're hoping for. Okay, so the problem here, how can we determine the amount of work done on an object? I think this might help. Just putting that out there. Okay, probably a good way to go. But we're actually going to be using our graph. We're going to be using our graph that we're going to make. It's still going to involve using this formula, just slightly modified. All right. So for our design here, identify our manipulated, responding, and controlled variables. Okay. So in this lab, what we're going to do is, as you can see in the diagram here, we're going to have a rubber band. Okay, and it's going to be put between the legs of two desks. All right, not one desk, two desks. All right, these rubber bands will not stretch across the front or back legs of one desk. So you'll have to put two desks very close together and then just pull them enough apart that the rubber band is taut. Okay, not tight, taut. Okay, just so that it's not hanging. Everyone with me there? All right, because if you have too much tension in it before you even get started, you won't get very good data. So we want it just so that it's not slack. Okay, everyone follow me there? Now, there's a few things that we have to be mindful of when we're doing this. The desks are somewhat heavy, but when we get pulling on this rubber band, with these spring scales, if someone's not sitting in the desks may move. Okay, will that affect our data? In fact, you will have to start over again if it happens. All right, because there's no way you'll be able to be sure you get the rubber band exactly the same way you had it when you first started. All right, does everyone follow me there? So it's very important that in your group, the job of two people is to hold the desks down. You're the bench warmers. Okay, you have to warm the bench and sit in the desks while the experiment goes on. That doesn't mean you're not going to be contributing. Okay, you'll be contributing by holding the desks, but you'll also be able to help with the measurement and stuff because you'll be able to look directly down over the ruler and kind of help people out with those measurements. All right, so we will have the ruler placed in between the two desk legs there, okay, and it'll be the zero of it will be right on the sort of the middle of the rubber band. Okay, so the zero will be right in here. Everyone follow me so far? Okay. Now, what we're going to do is we're going to pick some distances to pull or stretch the rubber band to. Okay, we're picking those. There we go. Okay, so we're picking the distances, and what we're going to record is what force is required to pull the rubber band to those distances. The way we'll get that is off of these little spring scales. Okay, these spring scales will record the forces required. Now, in order to get this to work kind of exactly the right way, we have to realize that when we start pulling on these, it is possible to max out the scale. We don't want to do that, okay? Because if we pick a distance that's beyond how far we can pull with the scale, are we going to be able to measure it? No. All right, so what I would suggest you do is kind of pull your scale. Your first trial will be kind of pull your scale until it gets to around, let's say, 1,800 grams or so. Record that distance. Okay, and then pick some distances between that maximum distance and zero. Everyone kind of follow me there? So your chart, of data, is going to end up looking something like this. All right, so you'll pull and go, all right, well, I was able to get to 0.3 meters when I kind of maxed out my scale, and then pick, as many even kind of displacements before that as possible. Okay. We're still going to be picking the distances, but in order to make sure we don't pick distances that are beyond what the rubber band can stretch, or this can go, we want to make sure that we kind of do it that way. Okay. Now, unfortunately for us, we do have one equipment problem. When we came to this school back in 2006, we ordered all new equipment, and we ordered these, except we didn't order these. We ordered ones that had newtons, which is the units for force, on them. We got these ones. They have grams and ounces on them. The box, however, shows the picture of a scale with grams and newtons on it. I don't know what's going on here. Okay? We tried to send them back, but they said, no, we sent you the right stuff. We argued, no, you sent us the boxes for the right stuff, but the contents of the box were not the right stuff. Anyway, they wouldn't refund our money. So, okay, what we have to do then, since we want the force in newtons, is whatever reading you get in grams, divide it by 100. That'll be your reading in newtons. Okay, that's not a difficult calculation, right? We can all handle that. Okay. Okay, that is not a source of error, by the way. Okay, I know maybe a few of you are thinking of that. That's not a source of error. We're doing a calculation there. All right. Okay, so for our hypothesis, okay, the hypothesis we're going to be looking for explains how, using the materials below, we can calculate the work done on an object. So I would say probably the if part of your hypothesis should tell me maybe what work is. Okay, and I'm not meaning quote the formula here. Tell me work is, kind of almost define it. Okay, the and part will describe the experiment. Okay, and the then part, tell me how you think you'll be able to calculate, okay, the work being done. Okay, using essentially the data that you're going to get in this lab. Now, once you've got your data filled in, okay, and so, you know, when we're looking at this here, we probably won't get to 30 centimeters, okay, and this, by the way, has to be in meters, okay, the distance has to be in meters here, right, so we probably won't get to 0.3 meters. I would imagine 0.15 is probably about as far as you're going to go before you max out the scale or the rubber band, okay. If your rubber band breaks in the middle of the experiment, what are you going to have to do? You're going to have to start over. Okay? I mean, these rubber bands are ideally supposed to be all the same, but can we be sure of that? No. And if we want to make sure that we have a nice kind of linear relationship, we have to make sure that all the data comes from the same rubber band. Okay? All right. So your chart, like I said, you're just going to make one up like this, okay, kind of on your own. Just roughly fill it in. There's one for that already in the Google Classroom version of this. Okay? You're going to graph this data as part of your analysis. Why does that keep happening? Okay, so in your analysis and interpretation, sorry, in the procedure here it says graph your data and draw a best fit line. Okay, so you're just going to use Google Sheets for that, right? Just open up Google Sheets in your Google Drive and enter the data. Okay, we're looking for distance on the X, so that means it's got to be the first column when you do it. Okay, force on the Y, so it has to be the second column. Okay, you'll fill in that data. Okay, get your graph, same as always. You do the scatter plot, put the best fit line, get the equation for the best fit line as the label, all that kind of stuff. Okay, so once you've got that, then okay, you're going to calculate the area beneath the line on your graph. Okay, now you may have noticed, maybe on your Need for Speed lab that you handed in today, okay, that sometimes when Google Sheets draws the best fit line, it doesn't go through the origin. So if I calculate the area underneath that, okay, how many shapes do I have? 2. I have a triangle, okay, and its height will be whatever the maximum line here is, okay, minus the y-intercept. Okay, and then the rectangle's area will be the y-intercept is the height, and however far it goes over is the run. Okay, everyone follow me there? All right, so when you're calculating the area, it may not be as simple as a base times height like it says here. It may be 2 shapes depending on where that line gets drawn. Make sure that you use 0 and 0 as one of the points on the graph. Okay, everyone follow me there? Right, because we know that essentially the rubber band doesn't have any, it's not stretched at all if there's no force on it. Okay. All right, so that's basically what 1 is talking about, is just being able to calculate the area. Okay, and then question number 2 is, what does the area under the force graph represent? How do you know? So you got to tell me what it is. I'm not going to tell you that, by the way. Okay, and explain to me why. How do you know that? Maybe talk about what units you would get when you when you do that calculation, okay, when you go base times height or whatever, okay, look at what units you might get from that, or what two things maybe you're multiplying together when you do that, okay, and that can be part of your explanation for what you're finding when you do that operation. All right. Okay, then your conclusion, okay, you restate your hypothesis, give me reasons for accepting or rejecting. Sources of error, I think you're going to find there's a few while you're doing this lab. Okay, and then obviously you don't have to do the class discussion. We'll talk about those, okay, when you hand it in. Questions so far? I think I made the due date December 11th. Okay, so it's a ways off yet. Any other questions? All right, so let's get the data acquired. Okay, that part should be pretty straightforward. Like I say, just pull it till you get to about 1,800 newtons. All right, on there, sorry, 1,800 grams, which is 18 newtons. All right, and record that distance, and then find some distances that are less than that, you know, to pull to. We're looking here, guys. I think it says, well, it doesn't say how many. We're going to say how many. We're going to look for 7. Okay, let's get 7 distances. All right. And you can include 0 in one of those 7, so 6 other than 0. Okay, everyone follow me on that one? Everyone's good with that? So once you have the data, I'll have the Chromebooks out here and you can get started on the lab report after that. Okay, so, spring scales. When you're grabbing a spring scale, there are 2 different kinds in there, 500 gram and 2,000 gram. Get the 2,000 gram. Okay, they're labeled on the boxes as long as people put them back in the right boxes. Okay, they should say 2,000 on them. When you pull them out, if they're red, you got the 2,000 gram one. Also, they go up to 2,000 grams. It's kind of a dead giveaway. Okay, if you pull one out of a 2,000 gram box that's green and only goes up to 500 grams, let me know and we'll get things back in the right boxes. Okay. All right, so meter sticks are there, rubber bands are there, spring scales are there. Okay, let's say groups of, 3 or 4. Okay. Okay, so if you're getting to the point where you're working on the lab report, I put a chart in here for you. I'm not sure why I did that, maybe just to remind you that you needed a chart in there, but obviously you don't have to enter stuff twice. If you enter all your data into Google Sheets, okay, so I've made a spreadsheet here of my data, okay, for this lab. All right, just highlight that stuff and then go into your, whoop, come on. Okay, then go into your Google Sheets here and just delete that chart by going into any spot in there and going into table and just go delete table. It'll get rid of it, and then I just pasted in the stuff I put in from Sheets and it works just fine. That way you don't have to do it twice. Save yourself some work. Okay, and then you're obviously going to have to graph that data, guys, same way we've always done. Insert your chart, okay, scatter charts, okay, click on that, and then go to customize, okay, and get all your other stuff in there, okay. Okay, and guys, on this one as well, you may want to put in more grid lines. Okay, might not be a bad idea. Okay, so guys, remember, once you've got that chart, that graph built, okay, you're just going to click up here, copy that chart, and paste it directly in here where it says Insert Graph here. Okay?